Good morning.
Morning.
Hey, Charlie. How are you
Hey Drew,
doing?
how you doing?
Oh, pretty good. So I
We,
talked that it's just the two of us. I was like uh computer rebooted. I was frantically getting everything running again.
I was looking saying, geez, did the meeting get canceled? I didn't see a cancellation notice.
Who knows? Um, yeah, and the one, I mean, I like working at Microsoft, but one aspect of it that makes life interesting is that we get all of the new versions of Windows and stuff. And so my computer seems to reboot a little bit more at work, getting beta versions of Windows. And it's nothing exciting. It's just something new. I don't even know the difference. But
Yeah,
I know my computer rebooted, and and I'm frantically trying to get to a meeting or something first thing in the morning.
yeah, I know it. It always happens that way, doesn't it?
It really does. Well, and just to have a few extra reboots a month, because I like to reboot it, like maybe once a week or, because I have a lot open.
Yeah, I
But,
noticed that I've switched now to a Mac, but I was on a Windows machine, and it seemed like the frequency of the messages coming would say, your organization, meaning Cisco, requires you to do these upgrades. And
yeah.
it was getting to the point where it was like every week there was some upgrade. And it's like, okay, that's not a problem. I can, just take the time to do that. If I didn't, it would do it automatically. But what was really frustrating is in some of the uh, reboots, I would lose some of my functionality or some settings would be changed. And then
Oh
I gotta
God.
go. So I used to have like a white background, then it became a black. And it's like, well, I don't want to waste any time going to figure out how to change that
Oh,
back to white. I'm just going to live with the black. But it gets to the point where things are so complicated that just getting back to where you were before takes way too much time.
yeah, yeah. I know. I know. If my desktop just stayed the same,
Yeah.
I,
It-
I'd be fine. I mean, I sound like my mom, you know. Why is it changing? But uh,
but remember the good old days, long, long ago, I think when Microsoft upgraded Excel from, I don't know, Excel 1 to Excel 3 or something like that, you had an option to pick Excel Classic, which would be all the old Excel stuff, not the new stuff, right? Where did
mhm.
that go?
I guess it's hard to maintain, but I don't
Yeah,
know.
I think that's the problem.
I used Excel and Word for DOS. Yeah, that was where I.
Oh, wow.
But yeah, I was a rebel. I wrote my thesis, and everyone at my grad school used LaTeX, and I did it in Word. And so I
Wow.
wrote this huge, 200-page document in Word for DOS. And Microsoft was actually pretty helpful because I had a lot of problems since Word wasn't really debugged for, like it was just an unusual use case. So they kept sending me at no charge boxes of disks because the software came on like I think 12 floppies, and so I kept getting these shipments of 12 floppies and updating my Word. Uh, I gave him a lot of credit for that, but uh, I don't know. Maybe I was using a master doc with subdocuments, and yeah, it was interesting. It was not the normal. So let's see. I think Am I sharing?
Yes,
Am I screen sharing? Or am I sharing the one window? I can't tell.
you're sharing the Google Doc.
Okay, okay. My thing isn't showing me what I'm sharing for some reason on Zoom. So I'm not sure where Yogesh is. Thanks everyone for joining. So I think our goal today is to sweep through the document again, close some issues, and see if we can get it ready to release. Did anyone else have any topics?
Looks
Okay.
like
Well, if
everybody's on mute.
yeah. Well, if that's not controversial, I'm just going to dive into the doc and let's get it reviewed and and submitted. If
That
you've
sounds good to
contributed,
me, Drew.
please. I'm sorry.
Sounds good to me.
Okay, great. And if you've contributed and you want to add your name, please do. Okay. I'm just gonna. Okay, we've got. Okay, I added. Um. Oh, I think I highlighted something here. Let's see. So, um, one of the things I changed in this drawing recently was CPADs, since that's the plan now. Um, I will double check that this looks consistent, but um, I'm not sure what to say about these GUIDs still. I don't know. Oh, and so gave myself an action item, which I didn't do. I'm sorry. I was on vacation last week. So I will work on this and have it ready for next week. I am so sorry. But I think we're just going to replace that with CPADs, and I'll clarify the CPAD and JSON stuff. Again, that's time slipped away from me. Okay, and I'll do that. I actually started working on that, so I'll keep working on that. Another thing I didn't do. I am so sorry. Um, but I'll add the scenarios document and remove these. Um, yeah, Antonia, I'm sorry, I want to cut you off.
Sorry, the mute button was not working. No,
Oh,
no, no comment.
oh, okay, no worries. I'm glad you're here, by the way. It's great to see you again. And look, I'm still using the mug, so uh, it really is great to see you. Um, okay. Uh, so I think this is started, and that's good. Um, and the conclusion. Okay, so let's look at the conclusion. So does anyone have any concerns with Yogesh's conclusion?
I guess my one question, Drew, is do we want to kind of commit like that LP6 is next?
Oh
Or do
yeah.
we want to say something like other memory technologies?
Well, and okay, and as far as data center things go, LP is the most broken in
Yeah,
terms of SDC and you know and fatal error rate. But I don't know if that's also the priority either.
yeah.
Um,
I'd say I get about half questions on LP versus HBM on
yeah,
what we're doing next.
yeah, I think we okay. So um,
For what it's
how
worth,
about
I have the same question about that. It seems like a random add-in for something we've discussed not at all above, really.
Yeah,
yeah? I think so, and I think it came from there's a lot of concern about uh, using certain LP is used in certain situations for AI training workloads, and the very, very large clusters, and so its reliability problems get magnified. But I agree. I think we should just. I'm just saying why I think he added that. It keeps me up at night. But I agree that we need to talk it through, and HBM is also very interesting. And in fact, I don't know if Roy is here, but Roy had. I don't think he is. Roy had mentioned that he was interested in um, talking about some HBM topics as well. So why don't we say future work will expand the framework um, to other memory technologies, including LP and HBM? Or do we want to just not say it at all?
I think I'm okay with that. It leaves it kind of broad in general, but specifies the kind of the two most likely next steps.
So is that is that okay with folks, or do we want to just say, other memory technologies?
I think if you want to just say additional memory technologies, including LPDDR and HBM, leaves it more open.
Okay.
It's not a hill I'm going to absolutely die on.
Yeah, I mean, we might do some work on DDR too. So
And when you say memory, would DRAM be better? Because I always think of memory as, well, there's flash and there's SRAM and there's DRAM.
that sounds good. All right, that's why we're doing it together.
The first sentence where it says vendor agnostic DDR memory. So I think this document was mostly focused on DDR5. So at least I think that's what we said right up front in the intro or some
Yeah,
section like that.
that's true. I mean, the list of things that we've created is particular to DDR5 presently because you think PMIX, right? They're DDR5 concepts. So that's a good point. So we probably ought to uh, discuss at some point anything that we think that we need to add for DDR6. And then there may be a question, do we ever want to go back to DDR4? Or do we just highlight the things? The DDR4 may be pretty quick because I think it's probably just a subset of the DDR5 style. But yeah, I think that makes sense.
And then
But
that sentence about, sorry, the sentence
no,
about
go ahead.
framework retains privacy. I think it needs to be softened a little. I mean, it almost sounds like this framework somehow, I don't know, it sounds like a promise or I don't know. It sounds a little bit.
Well, it does allow.
It allows, but it doesn't like, enforce it in any which way.
It's up to the vendor to do it. But how about supports vendor protection of or I don't know what to say. Like I guess the one thing I would say is that we're not. You can build a CPER and put proprietary information, and you as a vendor you can choose not to describe what you've captured without someone having an NDA. So how about it enables vendors to protect proprietary information?
Yeah, I think that's fine. That means that, the power is in the hand of the vendors, but yeah.
Yeah, and that is the key. Protect their intellectual property. And I'm gonna say, the promoting innovation is a following thought. It comes from protecting intellectual property.
Mm-hmm.
So that's why I got rid of the and. Okay. good feedback. If there's nothing else, I'm going to mark it done. Okay, and then I'll move that to a separate document. Let's. I gave myself a lot of action items, and I'm so sorry. I was on vacation last week and just totally uh, blanked. I ate a lot of good food, and I'm paying for it now. But so okay, let's look at the schema. Um, okay, and there.
Yeah, I think, Drew, I, I need to go clean this up some. We have kind of this example that Carlos put in initially, and then Owen took that a step further and did kind of put all of the table stuff above in the data to collect section into JSON schemas. But he has some updates to those that I need to re-upload, and then
Okay.
get some examples in here, if that's what we want to do, or if we just want to link to the examples.
So,
That's been on my list for some time and I haven't gotten to it.
I guess, yeah. So I feel a little nervous. I don't know, for some reason, without your guest here, but like, my question is, the schemas will be useful. Like if I make let's say that Microsoft or Google or someone is going to make their own processor, which they all do. It's no secret. Um, then knowing the schemas allows us to collect information and provide it to, code that maybe we could ask you to provide as we build analyzers for our silicon. And so in that regard, having the schemas documented somewhere is helpful. But it's also something the companies have to work out between themselves. And here's why I'm talking this way, is there are going to be a handful of companies that build analyzers. Obviously, AMD and Intel are working on it. Microsoft and Google might decide to do it. Some other companies that are making their own processors could do it, but it's not going to be everyone. People that buy off-the-shelf processors. And so understanding the big picture and these requirements meets the broader need of people that buy off-the-shelf parts. And so I'm just, in my mind, I'm debating, is this part of this document, or do we make the schema separate? Do we make it part of a discussion that we have with you when we make our own processor? I'm scratching my head. I'm kind of waffling here. I'm not really sure what makes sense. So I would really like to hear, Mita, Charlie, Antonio, someone from another company weigh in there.
Sorry
I'm
for the
sorry.
resounding silence, but
Yeah, sorry, Drew. I didn't quite understand the question.
Well, sorry, I rambled, but okay, everyone. I mean, okay, anyone that uses an Intel or AMD processor, or buys an off-the-shelf processor, benefits from reading these requirements as they're written, because they understand the big picture of what we're trying to do. But my point is that there is a vastly smaller number of companies that make a processor. And so when do you need to know this schema? This schema is you gather error logs in your CPRs, and then to feed them to the sub-analyzers that the memory vendor fault analyzer you have to convert whatever you logged in your CPR to a standard intermediate format, and that's what this is. This is saying, how do you talk to the memory vendors? And so my point is, the people that are writing error analyzers from scratch for their silicon is a vastly smaller number of people than people that use analyzers, because these analyzers hopefully are widely used. And so, because it's a different audience, I'm debating, does it fit in this doc, or is this doc so detailed that the typical user won't care, and we should just keep the schemas here? I don't know. And as Pure Storage and Cisco may have a different perspective, because my perspective is, yeah, I make processors. I'm kind of interested in seeing this.
So I think
So,
from a practical perspective, until we have some kind of proof of concept, this would be useful to have here, because otherwise it's going to be information scattered all over, and
okay.
we lose context the next time someone comes back to this and says, okay, now let's try to implement some of this.
Okay,
Yeah.
thank you.
Yeah, that makes sense.
Yeah. For me, the question is this, are we aiming to make this like, if you don't follow this schema, you're not OCP compliant? Because then you need this schema published. And it becomes a compliance thing. It's like, how do you know that the vendor was really following the exact schema, and that where the handshake fell is we're not
Yeah.
just going to make an exception? So I think you need to publish it, right?
Okay. Okay. And in particular, I think the schema is here. Like when you say yes, you have to pass the data to the DRAM fault analyzer from the memory vendor, and this means it would be problematic for the memory vendors to have to take wildly different information from every processor implementation out there. So I think that makes sense. I think you all have convinced me we should leave it in. But I was just probing. I just wanted, you know, a bigger perspective.
Yeah, right now I think it's we can think of it as our reference model, and that's the only one we have until implementations start coming in place, and then
And then we can revisit how we document
yeah,
things. Yeah.
yeah.
Okay, I buy that. That's actually very clear-sighted. Thank
Yeah,
you.
but remember, even when we have an implementation, if the implementation decides that we need to do something different, like that's the reason we need standards, right? You need somewhere to point at, like, I did this analyzer based on what? If we do it from a company, like I did it from my own micron spec, then that's not public, and that's going to be very hard. So they need to point out somewhere. So I don't think
Yeah,
we
I
can get
agree.
rid of this schema. At some point we always need to update it and make sure that, like, I'm working on this because it's in the OCP.
Well, it
Right.
may be documented elsewhere. That's all. It may be because my point was the audience for this document may be bigger than the audience for the schema document, and so maybe at some point we separate them. But I buy what Mita was saying, that I mean, and I agree with you, Anthony. I'm not pushing back. I was just trying to say maybe it's a different document, but uh, I think what Mita said was very clear-sighted, that we need it here for now, and that as this infrastructure matures, we may have kind of a high-level document like this that tells end users, the implementing data center flows, how this works, and a separate one saying, here's how you implement analyzers. But for now, it's one doc. And I agree with you and Antonio and Mita. So we'll leave it. But then what that means, sorry for scrolling, I just wanted to go to the picture, is we got to figure this out. And so I guess, Evan, if you could put the Micron proposal in, it looks like, um, the JM Lee also, gave some input. to this schema. Um, can you try to reconcile these two somehow?
Yep. Yeah, I can do that. I don't know that anything that Owen put in there is really outside of what Carlos and Jongmin had said above, but I'll go double check all that. Carlos's was just kind of a subset of what we had at that time, which was pretty
Yeah.
incomplete. And then Owen actually has a second revision that I haven't uploaded yet. So
Oh gosh. Okay.
I have some work to do there too. That after we kind of finalized the inputs table, he went and took another pass through it. So it should be pretty good, but I just need to go get everything updated.
Okay, and then my question would be next is this a micron schema or is it a a general schema? And ideally we would agree on a schema to the memory vendor analyzer that worked for all the vendors.
Right,
Yeah.
and that's definitely the goal. I was going to mention earlier that this, having kind of a standardized schema addresses one of the biggest pain points for us, which is a lot of that work with every vendor on figuring out how that's going to fit into a framework and
Yeah. Well,
get all that done. So
well, and today, I mean, yeah, today I've seen what you all do, and at one company I worked at, we gave you information formatted one way, and I think at a different company you get it formatted a different way, and you have to reconcile the subset of the data that you get and the different formats,
yep,
and then you want to do the same thing with all the data, but you don't have the same data and you don't have the same format. So I appreciate the problem uh, and so, yeah, if we could make it standard, that would be the dream. So the gas station down the street has a memory error. They grab error logs and they somehow find their way back to you. Maybe when they return the part, you say, "Go grab this data," and all of a sudden you can FA, a gigantically larger number of parts that come back to you.
yep, yeah, it'd help a ton. Yeah, and I mean, that is kind of a tricky line here. There's necessarily some amount of flexibility in this across vendors and across memory vendors
Mm-hmm.
and system operators, but um, being standardized without limiting here, as standardized as we can without limiting um,
Well,
functionality is
and
really what
maybe
we're
what
trying
we
to do.
could do is put, have a vendor specific section in this
Yep.
because I've always imagined, I keep coming back to, my dream is a time domain reflectometer in the PHYs that can tell where an impedance discontinuity is so that I can say, oh, your DIMM's not seated, based on how far it is down the wire. Or,
Yeah.
a VIA failed in your PC board. Or, I mean, not that that happens that often, um, but that would be highly proprietary because it's science fiction, and we need a way to include that though if someone has a breakthrough.
Hmm.
So yeah, I think if you could, is that something that you've already got? I don't really see that. So
I don't have it updated in any of the OCP places. It
okay,
Owen's latest version lives somewhere on a Micron server, but I'll have to catch up with them.
okay. Well, what I'm going to do, Evan, is I'm going to ask you to make sure we have a place for uh, a proprietary data from the SoC vendor.
Okay.
I mean, as long as it standardizes at least the base set of stuff you need, that's already great. The
Yeah.
intersection makes sense. Even better if it still works if you meet the minimum base set between
Well,
a
that's
bunch of
that's the
instruments.
that's the goal, and by having this in JSON, um, basically what you would do is you'd fill out the think of the stuff that's listed here as the baseline, and then if you have additional data, the memory vendors could use that to say, okay, oh, this looks like, like for instance, you might be able to build something that helps you tell if a DIMM is canted in a socket. I mean, let's say it's some sort of, I'm just science fiction again, but a capacitive sensor. And so if you have a DIMM canted, indicator, you could pass that, you know, to the um, to the memory vendor, and if they can use it, they can use it, and if they don't, they don't. It looks like I need to turn. But do you follow what I'm saying, Sean?
Yeah, no. I completely understand being able to provide additional information for fancier features. I just mean, as long as we get the base stuff, and ideally it's a NSI where it continues to work. That's all I'm hoping for, because we got to get
Yeah.
someone internally to write one of these, and it's also slightly useful if
Okay.
versions
Well,
change
yeah,
over time.
exactly. And it is, but it's really important to me that we can support proprietary, innovative features. So that sounds great. If we can do that, then you can innovate too. So okay. I think we've got a plan then for that. I'm going to look and see if there's anything we can work on above. These are pretty easy to fill out, so I can do that later. Is there, okay, yeah, I guess, is there anything that people see? Well, we can brainstorm a list here. Um, I think CPADs, well, we call it a UEFI CPAD, and that is very speculative, but I think it's reasonable that we're going to, ask UEFI to define the CPAD format once we've got a definition for them to use. Just trying to think. Is there anything else we need to?
So I never actually really understood this section. What does complementary enablement in industry mean? Does it mean that something has already been implemented according to the FMFM framework, or what does it actually mean?
Well, that's a really good question. I think it means that we have dependencies and or need to go do we either depend on something or we need to go do work to make something happen.
So depend on something will be something that would be captured in references, right? Like
well, not necessarily. Like depend on a change somewhere. So yeah, if it's just like okay, well, we're assuming that you use DDR. This is for DDR5. Then you can put a reference to the DDR5 spec, and that's a already met dependency. But like JEDEC has come to us, and Yogesh is working on this to say, hey, if you're building these analyzers, how could you use the SPD EEPROM, and how big should the SPD EEPROM be? And so this is amazing to me that JEDEC is asking this of us, and it's but that may be a dependency. If we decide to use an SPD extension, then we would say, okay, we're building something speculatively, saying we need JEDEC to expand. And so, like we're saying for RAS actions, we need to JEDEC potentially to help us uh, define more of those.
so okay, so then if it's still in the works and it's somewhat speculative, can we even say that here, like, has that JEDEC's going to be working with us on X and
Well,
Y?
I think they already are, but because we're most of these companies are JEDEC members already, but in like UEFI CPAD, we haven't defined CPADs fully yet. We're working on that in RAS API, and we're a long way there. We've come a long way, but we haven't proposed that. So that's a thing that we're going to have to do at some point, is get that approved. So it's speculative, but it's also something that we think we can drive.
Okay, I mean, I guess my concern would be it might end up becoming a similar situation like the PCI SIG thing. I mean, can we say this here if if it hasn't yet been worked out.
Well,
And I mean, it's not like I've done this before either, so just kind of talking through it.
yeah, I think that what's happened with the PCI SIG is that people uh, uh, went beyond what was reasonable, and like there was a a company, or not a company, a group that was cutting and pasting the PCIe spec and building something, and that was maybe not the best practice. In our case, we're building a framework and we're building proposals to the spec organizations, and we'll run them through the um, normal things. But the things that we're discussing publicly are parts of specs that are also available publicly. So anyone can go down. You can go immediately and download the UEFI spec and not be a UEFI SIG member, right?
Okay.
So I think it's a little bit different because UEFI is a little bit more open, but I don't know. So um, we can try to ask. I can work with you, Gus, to try to make that clear. But what else do we need to include? Are there any other specs we need to change? I can't think of anything. I mean, I think that this is pretty complete for the moment. And what we probably will do is we define RAS actions, ask for changes. But and like when we do this future work, like store relevant information in SPD, um, then that would be another complementary enablement. We would need to do that with JEDEC, and because that is buried in the JEDEC spec, we do have to have an agreement to work with them, and so Yogesh is working with JEDEC. So and JEDEC actually came to us and said, we want to work with you on this. They actually suggested it, which thrills me. So this is good. It's a sign that we're doing something right. So I think this is good enough for now. I can't think of anything else. But if anyone does, please speak up and we'll add it. And then for future work, um, I think we've got a pretty good list of things here. I'm going to add DDR6 and DDR4 as a potential future topic too, because they're obviously interesting. And I think Roy was interested in HBM. Are there other topics y'all want to propose, or you have any opinions on these?
I just have a question. So the walkthrough memory scenarios, is that still this spec, or I think you'd mentioned wanting to move it to the hardware
It's the
quality?
other. It's the other spec. Um, but my goal is to create. What I'm trying to do, and I've written it up. I mean, it's largely out there, and I'll link it. And I've shown it in FMFM, and I've given links here before. But my goal is to show people the subtleties of um, memory errors and explain to them why they can't just count them and be done. And why it'll end up being, hey, look, memory error analysis. There's an art and a science to it, and um, it's highly dependent on the OS's behavior and the existence of a patrol scrubber. And we can walk through the memory scenarios I've written up are really showing people that these analyzers are valuable. That having an analysis tool that can figure things out will be good for you. Um, but we may have some other scenarios as well. I think um, one scenario I would like to walk through, and so this is good. We've got uh, existing uh, memory, and we're not going to leave this like this. We'll clean it up. But okay, existing memory error logging analysis scenario will be one of them. But I also would like to discuss for the future using analyzers to vindicate poisoned memory and enabling clearing the poison. So today, if something gets poisoned, the OS, all it knows is when I touch this memory, I got poisoned. And so it immediately maps the page out. And that's actually a reasonable thing for the OS to do because it doesn't know whether that memory caused the poison or whether the poison was from a PCI device or some buffer in the system that could generate poison. But if we have an analyzer that says, well, the poison came from this PCIe card, we could send a CPAD back to um, the OS saying, this memory is okay. We don't think it's really bad. You can clear the poison and resume using the memory. And I don't know how important that scenario is. I think it might be important when you talk about huge pages, 4 gig pages, it's more interesting.
Yeah, yeah, that sounds like a very good topic, Drew.
Thank you. There's some other scenarios I was thinking about, but my goal with the scenarios is to establish a baseline understanding of, so I've got a poison document uh, that I think is almost ready to share, and it talks about how poison is handling, and so I'll add that too, poison handling document. Um, but I'm trying to write it as a reference document that I want to submit to the hardware fault management group, and the point of it is to give people a baseline understanding of how poison works and what to think about when you have an application that gets killed by poison. And today, everyone tends to, not everyone, but it's most commonly assumed that memory is the culprit. And often memory is. The uncorrected memory ECC errors are one of the more common reasons poison is generated. But it can also be HBM on a PCIe card that gets DMA'd to memory. And the other thing that we want to figure out is, so we want to distinguish poison creation from poison consumption. And poison consumption guides the behavior of software. Poison creation guides the behavior of what do you replace. And so I want to connect the dots. And so if we can write these memory error logging analysis scenarios, if we can talk about how to vindicate memory when it's not the culprit, or how to handle poison and contain errors, we can establish a baseline understanding and prevent a lot of thrashing and gain more traction in the schemes that we want to build, because the way that we're designing things would be based around a common understanding. And so, like with a poison handling document, I'm not trying to invent anything new. That's not the point. It's really just to explain how it works, because uh, I've had some pretty wild ideas from kernel teams at every company I've worked at for handling poison. And so if we can get that common understanding, we can maybe tame some of the wild ideas and then start building solutions together that take us a better direction for poison. So I don't know what fits here or what fits other meetings, but maybe what we could do is, as we walk through these scenarios, is at least glance over them and decide what we want to walk through here. And then, we can say some of them will cover other places, but you'll be aware of it and you can look at the document and provide feedback. I don't want to blindside anyone. So is that okay? I mean, do you all follow what I'm trying to do with these walkthroughs?
I think it sounds great.
Yep.
Okay, it's interesting. Velos has been vigorous in his review of the poison handling document, and I love it. But basically, what he told me is true. I see so much confusion on this. I need something to share with my customers. So this is great. So that's the answer, right? Is that if Velos agrees and I agree and you all agree that we're the experts, agree on how poison should work, then we can start handing it to people and and make our lives better because people will be, just doing more of what we want to do. Okay, are there other things we want to cover in future work? Are there other scenarios you would like us to consider?
I don't know if this is specific to memory, but we did start talking about it at some point. Error injection as a whole might be a
Yeah,
good one.
I think I'm going to make that that's always a separate topic, but that is a good call because I know how to inject memory errors on most CPUs, but I don't know how to inject like a PMIC error, right? Maybe I just have to spoof that, but I think that's a really good topic. And the other thing that's interesting about error injection is that if you make it powerful enough, you can validate the design of the ECC, and that's a useful thing. We want that. We want a more common understanding of ECC. So I've in the past, well, pretty much everywhere I go, I ask for more air injection, and we end up saying, "Hey, can we inject more bit flips so that I can ensure that I get the right ratio of uncorrected errors to STC?" And there'll be some STC if you flip enough bits, and we understand that. We don't panic, but we want to make sure that the ECC is as effective as we expected. So that's a great topic. Okay. Well, I really apologize for not making more progress in the document. I was playing catch up yesterday. I will get to work, and for our next meeting, I expect to have more done. So I think with that, maybe we can end a few minutes early today, unless someone else has something to cover. I guess not. Okay. Well, thanks,
Yeah.
everybody.
Thanks.
Thanks.
It's
Bye.
great to have you here, and I really appreciate the help on this. And please take another look at the doc and give us feedback if you see something that looks wrong, because we do want to get it published shortly. Okay. Have a great
Okay.
week.
Thanks. Bye.
Talk to you later. Yep. See you.